Most students look at the function and freeze. They see curves, lines, weird shapes, and think it's impossible to understand. But what if I told you every function you've ever met comes from just a small family of parent graphs? Welcome to the ultimate guide to functions and transformations, the video that will finally make everything click. Today I'm going to show you the secret blueprint behind all graphs, the 8 parent functions, the superheroes of algebra. Once you recognize these shapes, you can transform anything. You learn how a simple move inside the function shifts an entire graph, how one negative sign flips everything upside down, how stretching just one number can turn a cute little function into a monster, and then the master key, the ultimate transformation formula. With this one formula, you can take any function and sculpt it into any shape you want. We'll build function machines. We'll break the domain traps that confuse millions of students. And you will finally understand the composition, not as messy algebra, but as a pure logic. And finally, we'll unlock inverses, exponential and logarithmic reflections, how to reverse any function, and how to prove with confidence that your inverse is correct. By the end of this lesson, you won't just memorize transformation. You'll see them, you'll feel them, and for the first time, you have complete control over the graph. So let's begin. This is Function and Transformation Mastery. Let's transform the way you think about math forever. Yep, so you got the concept. So again, we understood that at this point we do have two important parts. Either I have to move it some kind of vertical wise, or I have to move it horizontal wise. Where's the vertical wise with if I do have a number beside my f of x, g of x, or whatever, it means that that number is not inside the parentheses. But if I do have that specific number inside the parentheses, I have to be careful. If I do have a negative sign, I have to move it to the right. If I do have positive sign, I have to move it to the left itself. So let's talk about mirroring. We were talking a little bit about inversing and how we do have y is equals x as a mirror. X is equals e to the power of x and f of x is logarithmic of x. But let's just talk about it. What would happen if I do have a negative sign beside x? Because the only thing that we just saw right now was what would happen if I do have a number beside the parentheses, and what would happen if I do have a number inside the parentheses. We still haven't talked about what would happen if you do have a negative number beside the x, or if I do have another number beside the x itself. For example, y is equals f of 2x, f of negative x. So what would happen on those times? Let's talk about it. So the very first thing that you have to do is that a couple of things. The reflection across x-axis, it would happen if I do have the negative sign outside of f of x. Means that something like this. Imagine that you have y is equals square root of x as my reference, and if I do have this guy, a negative sign outside of f of x, the only thing that I have to do is I have to flip this guy based on what? Based on x-axis. It means that x-axis is my mirror, and whatever value that I have to move it over here on the bottom. So you have y is equals negative of f of x. Same time, if I do have the negative inside the parentheses, instead of just having x-axis as my mirror, I do have the y-axis as my mirror. So I do have move everything that over here to the left side. So remember, -1 outside, x-axis is going to be your mirror, -1 inside, y-axis is going to be your mirror itself. So let's have a couple of examples. Y is equals negative x to the power 2. It means that if I do have this guy as my some kind of reference, let me just draw the reference itself using another color. So I do have x to the power 2. It's going to be something like this, and negative. So as you can see, the negative is outside of f of x itself. So when outside, x-axis is going to be mirror. So this is my guy. So I do have negative h of x is equals absolute of negative x. So the negative is inside. It means that if I do have this one as my x, the only thing that I have to do, I have to invert it through the y-axis, which you can see nothing would change. It doesn't matter if I move this guy and that guy to the left and right, still that guy was symmetrical. So at some point, some kind of function wouldn't be change. At another point, I do have negative e to the power of 6, so I believe you can imagine what would happen. And you also can do everything over here, and you also have the answer. Try to stop the video and pause the video and think about it. That what would happen so far, we had the vertical shift and horizontal shift, and right now we do have the mirroring. We do have the x-axis as our mirror, that it would happen if you do have the negative sign beside your f of x, and we do have the y-axis as mirror if you do have f of negative x. Try to completely understand it, then pause the video and try not to look at the answer. I gave you a little bit hint beside each answer itself, but just think about it by yourself. Again, my way is to you guys to completely understand it rather than just memorize it. Try to do it by yourself, try to think about why that specific thing is happening, and move forward, because right now we are going to talk about another thing. So at this point, we do have the stretching and compression. What does that mean? So far we talked about the number beside of inside f of x as just positive and negative. So what would happen if we do have the numbers as the coefficients? So if you remember, we had y is equals mx plus b. The only thing that we just learned right now was yx plus b or x minus b, or y is negative x plus or minus b. So at this point, we do have two kind of conditions. If I do have that specific number is bigger than 1, like the way that we do have it over here, or it would be better to say that we do have 4 conditions. We do have one condition that our number or the coefficient is going to be beside the f of x, and we do have another condition that the number is inside the f of x itself. So if at the first point I do have some kind of value, or if I do have the absolute value, specific value is going to be bigger than 1, I have to vertically stretch that. You can see that y is equals sine of x is something like this. Again, don't worry about that. Y is equals to sine of x is a very common function. We will talk about it in the future and how we can use it. Just right now, just accept it as the way it is. Y is equals to sine of x is something like that one. So what would happen if I do have that guy inside it? It means that y is 2 of f of x. So you see that I have to stretch it towards the y-axis. It means that whatever value that I had before should be multiplied by 2, like this one multiplied by 2 itself. So at this point, what would happen if I do have a number, the absolute of that number is going to be between 0 and 1. So at this point, I do have a compression. It means that this guy, for instance, I do have y is equals half of sine of x. Since this number is between 0 and 1, this guy should be like this. Still the same thing is happening. Instead of just multiplying whatever value that I have by 2, I have to multiply by half. So obviously, as you can see, it's going to decrease. On another hand, so that was condition number 1, that's condition number 2. On another hand, if I do have my value, or if I do have my number beside the x itself is going to be bigger than 1, and I know for a fact that number is inside f of x, that thing should be horizontally compressed. It means that unlike this part that I have to stretch it, I have to compress it toward the x-axis. So it would be something like this. And by what factor? By factor of 1 over b. And at the same time, if I do have something like this, this is condition number 3, and if I do have something like this, I have to stretch that one by a factor of 1b. So why that thing is happening? If you want to some kind of intuitively understand it, what is going on, I would really recommend you just choose a couple of points. For example, 0, 1, 2, 3, negative 1, negative 2, negative 3, and put it inside your specific function itself. And try to start with a very simple one. For example, y is equals to x. Try to draw that one, and after that, use this number and try to compare it with different kind of conditions. Y is equals 2x, y is equals half of x, or y is equals negative 2x, and whatever you just see. And after that, you can completely understand that what is going on and memorizing, because at this point, I have to say some of these ones should be memorized. And these guys are going to be simple to be memorized itself. So don't worry about it. It's just a matter of practice. And remember, practice makes perfect itself. So at this point, we can just do a couple of examples. 3x, g of x is 3x to the power 2. It means that whatever value that you have, this guy is x to the power 2, you do have it at 3. So you have to stretch it, right? What does it mean by stretch? It means that whatever value is over here should be multiplied by 3. Whatever value, multiplied by 3. Value over here is just 0. Value multiplied by 3. And if you draw that one, it would be something like this. As you can see, it is increasing faster, and that's completely obvious. On another hand, we do have something like this one, half of x. Since this number is some kind of the half itself, so this is between 0 and 1. If I just draw it like that one, this is my V shape, or this is my reference. Whatever value that I have to multiply it by what? By half. So that move like that, and your V shape is going to be a little bit wider. I believe you also can do that one. It's not very hard. So you do have this one 2 inside the f of x. It means that you have to what? As you can see over here, since the number is bigger than 1, you have to compress it. By what value? By the factor of 1 over b. And at this point, you do have x times 1 over 3, so you have to stretch that one. So right now, let's talk about the ultimate transformation formula, because so far we talked about the shifting up and down, left and right. We were talking about the mirroring. We were talking about the stretching and compressing, but we haven't actually combined all of those together in order to see that what is going on. So this is very important. Why? Because we are going to combine all of them, and by using all of them, we are going to see that what would happen if I do have any kind of number, if I do have it beside the value, if I do have beside f of x, if I do have it inside f of x, if I do have just some plus k or negative k. So what would happen on that time? So this is the final formula, and I really suggest you guys try to memorize it, to understand it, because for some kind of test or for exam, or some kind of professor is not going to give you something like this. So the professor is going to give you an example, and after that, based on an example, based on this some kind of main or ultimate formula, you have to apply it through your question, and after that, find the final answer, right? So y is equals a times f of b parentheses x minus h plus k itself. So at some point, maybe some of you would get a little bit confused at which one should come first. Again, doesn't matter. You can start from whatever you want, but I suggest you guys to start from the inner side, and after that, move to the outer side. And do it step by step. Before that, before just doing everything, try to make some step inside your head, and to see that what is the first step, what is the second step, what is the third step, and make sure you did all of that. And after that, just try to apply it over to your final answer itself. So at this point, I do have my b itself. As we all know, b means that the horizontal either stretching or compressing. It means that either I have to make it bigger, stretch it, or I have to make it smaller based on compression. After that, we do have the shifting on the horizontal side. You remember, if this sign was negative, it means that I have to move it to the right. If the sign was positive, I have to move to the left. And if I do have this some kind of stretching and compression, so I do have it over here. If that number was bigger than 1, I have to stretch that. If the number was between 0 and 1, I have to stretch that. And after that, at the end, I do have the vertical side, means that shift to the top or to the bottom itself. So let's see an example. I do have y is the square root of x as my reference, and after that I do have this guy as my some kind of changed function. So my new function is like this, and the question is already asked how I can draw that. So again, as I just told you, try to start from the beginning or from the inner side, move to the outer, and do everything step by step. So imagine that I do have my first step is y is equals root of x minus 3. So since I do have minus 3, it means that I have to move this guy 3 to the right. So this is the first step. The second step is y is equals 2 of root of x minus 3. So since it is 2, it means that I have to stretch this one, or I have to some kind of make it stretch it through. I have to stretch that one through the y-axis, right? Whatever value that you have to multiply 2. So it's going to be something like this. You do have this one. After that, you do have the negative sign. Since this negative, or the third step, is y equals negative 2. Since this negative is beside the f of x, it means what? It means that my x-axis is going to be my mirror itself. So I do have x-axis, so this guy is going to be something like that. And at the end, I do have the positive one itself. It means that I have to shift this guy 1 to the top. So it's going to start somehow like this one, and you have this. I really suggest you guys to use the pencil. It means that after each point, or after some kind of each step, By the way, this is the last step. After each step, you can just get rid of the previous step and you can have your final answer itself. That was like this. So you also have a couple of more examples over here. You can just draw it by yourself. And at this point, I gave you a couple of hints in order to you guys see that how you can do them. But again, try to pause the video, try to think about it, try to do it by yourself. It doesn't matter how much does it take. Try to understand it first. After that, see the answer. So when you see the answer or hint, you can right now think a little bit more about it, do it by yourself, and again, do this routine one time by time. At the end, you make sure you completely know what is going on, and after that, you're completely 100% confident in your exam itself. So far we were talking about y is f of x, right? What would happen if we do have the combination of functions? Maybe it would be a little bit strange for you right now. What does it mean, a combination of function? So it means that at some point, instead of just having as y is equals f of x, so what was y is equals f of x? It means that your input is just x. But at some point, your input is not only going to be x itself, your input is going to be output of another function. So we call this one as the function composition. It means that f of x doesn't exist anymore. I do have f of g of x, or I can write it down like this. F of g of x, or f of gx, sometimes we call that one. So it means that you plug one entire function into another one. So you already had x, you put it inside the first machine, that was your g, and you get g of x. After that, this g of x is going to be input of the second machine, so you have the f of g of x. If I want to give you a real world example, imagine that you just go to UK and buy a shirt. So that in UK we do have a 20% of tax, so g of x is going to be 1.2x. So on that point, if I had some kind of my t-shirt as 10 pounds, the output is going to be 12 pounds. If you guys would like to convert it to dollars, so we do have a specific formula for that. It means that your input is not going to be 10 pounds itself. Your input is 12 pounds, that we already got that from the previous function, and at the end we do have the $15. So that was the two-step method. What would happen if I would like to have would like to combine those? So at that point I do have f of g of x. It means that my f is going to be just the function itself, the way that I would convert my pound to dollar by just multiplied by 1.25. Oh, if we imagine that is going to be your rate, and after that 1.25 multiplied by 1.2x. So 1.5x is going to be my combined step, or f of g of x itself. So for the next time, the only thing that I have to do is just put my input as the pound itself, and at the end is going to give me the dollar. So as you can see, this is the function composition itself. So let's just have a couple of examples that what is going on inside that. Imagine that f of x is equals to be x to the power 2 plus 3. And after that, my g of x is 2x minus 1. So at this point, I would like to find f of g of x. So since f of x is some kind of x to the power 2 plus 3, in just some kind of normal condition, the only thing that I have to put as input was x. But at this point, my input is going to be different. Actually, my f of g of x is going to be g of x to the power 2 plus 3. What was g of x is going to be 2x minus 1. Why we would like to have that? Because at the end, whatever value or whatever formula that you find should be based on x and x only itself. So at this point, I do have 2x minus 1 to the power 2 plus 3. So how I can find the 2x minus? Simple, 2 times 2x minus 1. So this is about the two terms. Right now we don't know anything about that. Maybe some of you in the future I will talk about it. But at the end, if you some kind of simplify that, at the end you do have something like this. So this guy is the f of g of x. So another question is that what is the g of f of x? At this point, instead of g being the input into f of x, f is going to be input inside the g of x. It means that my g of x was already 2x minus 1. But my g of f of x is going to be 2 times f of x minus 1, right? So what was my f of x? It was x to the power 2 plus 3 minus 1. This is simple. 2 times x to the power 2, 2 times 3, and subtracted by 1. So you do have this guy as your final answer. So what is the f of g of 3? It's simple, because I don't have to do anything. Either I can, again, do all of these steps from the beginning, but instead of x, use 3. Or since I do have this guy, I only have to put 3 inside of that, and I do have the final answer itself. As simple as that. So there are some kind of tricky parts over here that you have to be careful. If you guys remember, when we were talking about domain, for example, y is equals over x, x shouldn't be 0, right? So at this point, when you do have the combination or you do have the composition function, you have to be careful because your domain not only has to follow whatever value g of x is going to accept, you also have to consider what would happen if I move g of x inside the f, because obviously f has some construction. If I do, f has some kind of limitation, right? So at this point, we do have some kind of two things or two domains combined to each other, and at the end is going to give me the final domain for the whole thing itself. So let's have this example. Imagine that I do have my f of x is square root of x minus 5, and my g of x is x plus 2. So obviously, as you can see over here, the domain for g of x is everything. I don't have any problem with that. But as soon as I put that guy inside this one, the very main or the main f of x had the domain of x bigger than or equal to 5, right? Because we know the value shouldn't be negative inside the square root. But at this point, my value has changed. At this point, I do have x is bigger than 3. At another simple example, but I do have 1 is equals over x, and g of x is x minus 7. So the very first part was x cannot be 0, but as we can see over here, x cannot be 7. So my domain has changed. So please be very careful. This is going to be so troublesome for you if you don't understand it, what is happening. So some kind of the final part would be about the inverse function. What does it mean by inverse function? Means that f to the power of -1 of x. And this guy does the exact opposite of f of x. For instance, if f of 3 is 10, then f's inverse of 10 is 3. So what is happening over here? If you guys remember, when we were talking about machines or when we were talking about the function, we had x as our input, and after that we had y as our output. So maybe some of you would ask, I know for a fact that x is going to give me some y. It means that if I do have x, I can find my y. But what would happen if I do have my y or my f of x and I would like to find my x? So this is going to be considered as inverse operation or inverse function. Rather than f of x, we are talking about f to the power of -1 of x itself. How we can show it on the diagram? Simple. At this point, if you guys remember when we were talking about e to the power x and ln of x, I told you that these two guys are reverse. It means that if you use the y is equals to x as your mirror, whatever value that you have is going to be reflected to ln of x. We don't only have these guys, we only have other kind of guys. Imagine my f of x is x to the power 3. My f inverse of x would be something like this, and I know for a fact that whatever value that I have over here, its inverse would be over here itself. So the very important thing, oh, by the way, the graph of f or of f to the power of -1 of x or f inverse of x is a perfect reflection of f of x across the line y is equals to x. All the time y is equals to x is your mirror. So maybe some of you would ask how I can understand that, because at some point maybe I don't have any inverse. I cannot find any number, or at least there are two numbers or maybe more than that. So at what point I can understand that for sure, for a fact, my function has an inverse? It's simple. Just draw the horizontal line. For example, y is f of x is x to the power 2. I would like to see that if I do have any f of -x itself. So if you just draw a horizontal line, and if that horizontal line has intersection with more than one places with your diagram itself, it means that that guy is going to fail to having the inverse itself. Therefore, it does not have an inverse over its full domain. And after that, we are going to talk about it in the future. But right now, the only thing you need to know is what is the meaning of inverse function and how we can understanding and drawing that a function has an inverse or not. So at this point, we are going to show you the four simple step that how we can find the inverse of something. So it is easy. So the very first thing that you have to do, replace of f of x with y. For instance, let's just talk about it. F of x is equals to x plus 5, and I would like to find f of f to the power of -1x or f inverse of x. I would like to see what would that happen. So f of x is equals to x plus 5. I have to replace f of x with y. So simple. Instead of just having f of x is equals to x plus 5, I would say that my x is equals to y plus 5. And right now I have to solve y based on x. So it means that swap every x and y itself, the way that we just did it, solve the new equation for y itself, and replace your y with f inverse of x. It means that right now I have x is equals to y plus 5, and I have to solve this one again based on x. The only thing that I have to do is replace my y with f inverse, and right now I do have my answer itself. So it means that whatever value that I put in order to find my output, I can use it over here in order to find my input itself. It's some kind of two-way road of considering the function and inverse of the function. So again, if you would like to find the inverse function of this guy, you can see that over here by some kind of restriction, because if you remember, f of x is x to the power 2, doesn't have any inverse. But if I consider some kind of domain restriction, I'm good. Why we consider that domain? Because as you can see over here, if you just try to find f to the power of -1x, you do have the square root of x. So if you remember, square root of x cannot accept all of the numbers. The x cannot be negative. But based on that specific question, if we don't consider x is bigger than 0, we are going to have some problem. So it is very important to first we know that the function that we have has the standard domain for ourselves, and after that we can use, and after that we can find the inverse for itself. So this was about the very final slide, and some kind of the power of inverse was about exponential and logarithmic. We were just talking about it, that as you can see over here, if y is equals e to the power of x, and f of -x is going to ln of x. I will talk about it in the future, don't worry about it, but just remember that when your f of x is e to the power of x, your f inverse x is going to be ln of x. I will talk about it why. So far we touched the function part. What was the function? Function is just like a machine, and that machine, you have some input and you get some output. We were talking about drawing and what would happen if we do have some kind of transformations, what would happen if you have to move it to the top or bottom, stretch it or compress it, and after that what would happen if we do have some kind of mirroring situation, what would happen if we do have compound or some kind of composition part, that we do have the combination of two functions. We were talking about the inverse functions, and I believe right now you have a very good understanding that what is happening inside the function itself, because function is a very important part of the algebra itself. Again, try to rewatch the video, try to solve all of the questions. If you have any problem, please comment them down below. I'm trying to help you, and if I couldn't, I will make another video for you. Please like and share and comment, and try to share it with your friends. That would be so helpful for me. Have yourself a great day, night, whatever. See you around.